How long will your Dometic RTX 2000 run on 100 amp hours of Victron lithium power? I don't know, but let's find out. Okay guys, right now we're at 13.3 volts. This battery can go all the way up to 14.2 safely with no problem, so we're not at 100%, but just for the sake of the video, we are going to go ahead and start it at 100% state of charge at 13.3. I really want to put an emphasis on how many amps it takes to run this in this temperature and how many amps it takes to run it when we move it outside to a hotter temperature. There is a difference, and when you're calculating how long your air conditioner will run, it's important to run those calculations based on a low temperature and a hot temperature as well. So guys, let's just go ahead and get into it. Let's press power on this thing. Let's see exactly how long it will run for on 100 amp hours of Victron smart battery. Let's get into it. We've got a Dometic RTX 2000 in white. We've got one in camo, so you see how badass this thing could look. Go ahead, take a look at that. Go back over here to the white. They don't come like that. That's for a special mission. Okay, I've got 100 amp hours of Victron power down here, loaded up to 13.3 volts. This is a Blue Sea 120 amp breaker that we just keep on the cart. And this is the only breaker I like to use with AC units. We're at 13.3. We're still screen recording. Let's go. Kenny, can you grab the handheld camera and let's get under here. We're going to press the start button on this and let's figure out exactly how long this air conditioner will run off 100 amps of lithium power at 75 degrees. Come on down low with me, Kenny. Can you get under here? Can you see this, Kenny? Make sure that my fingers look pretty in the picture. Okay. All we're going to do is press and hold that. Okay, give it a couple seconds. Don't rush it, guys. Don't keep pressing it. Give it a second. It's thinking. Thinking, 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 thinking. There it goes. It's slow, but she's got to make sure that everything's right before she gets rocking. Okay, so there we go. Okay, so let's set the temp as low as possible here. Is that as low as she goes? So that's 62 is as low as she goes. We've got it in cold. Let me show you what the rest of these things do here for a second. Mode, fan, timer, cool, set it to the temp. Okay, and we got it all the way down. Let's give it a second for that compressor to kick on. There it goes. Do you hear that, Kenny? So the compressor just kicked on. So we're at 7 amps. Okay, I'm screen recording this whole thing right here. 9 amps, now it's rolling up. Okay, 13, 14, 15, 16. Okay, so right now we're at about 22. Now you guys can't feel this, but it's actually coming out quite chilly under here. I'll get a temperature gun here in a little bit and do a little reading for you. But right now we're at 23 amps, okay, and we're at 75 degrees on inside, okay. This temperature will start going up. This temperature is also on the electrical wires. So as we start passing current through here, this temperature will increase. It's not actually the temperature in the room. So right now, what you can see here is that the time remaining, because I've got it based on a 100 amp hour battery bank, says that it'll run for 4 hours with a 10% discharge floor, which means we're not going to use 100% of the battery. So this will start automatically changing, and it's saying about 3.5 hours now. That'll adjust. Guys, it's 2:49, so we started at, I don't know, around 2:45. So that'll be our timer right there. And we're basically going to wait until this thing's done. I don't think it's a full test or a great test because we weren't at the 14.2 amps at the top end of what this battery can hold. That's just poor planning on Kenny's part. He should have charged the battery before we did the test. But what are you going to do? We use these batteries every day around here to test a whole slew of things. There we go. Now let's just sit back, relax, and go further in comfort. Kenny, that's a bad angle. Don't get it. So guys, this is the Victron Energy BMV 712. Right now we're at 13.7 amps. We're getting a little bit of voltage drop since we're taking so many amps out of the unit, which is, but we also didn't charge the battery all the way to the top like we should have. But if we scroll down here, right now we're using 27.5 amps out of the unit. So this here is pretty constant. I will notice though, when we do this outside and it's at a hotter temperature, this number will go up, okay? So just go ahead and keep that in mind. This will fluctuate a little bit. And then right now it's using 385 or 86 watts. That'll fluctuate a little bit too. And then right there, 13, we'll keep it right there, guys. And we're just gonna let this thing run and see exactly how it ends up. A lot of comments in the last video, the unboxing video we did about this, about the fans. Now, do you hear that kick up? Okay. Guys, these fans are outside your van. Okay, they're not inside your van. Okay, you won't hear these inside your van. It's not overly loud here. It comes across very loud on Kenny's very nice camera setup, but in reality, like, I'm not raising my voice to talk to you, but inside your van you shouldn't hear these fans. The only fans that you should hear are the fans inside, and that the noise volume is controlled completely by you on how high you set the fan speed. So just remember that it sounds worse on camera than it is in real life. So right now the fans are going a little faster, and the compressor itself and the whole AC unit moved all the way up to 33.4 amps. Okay, and what that is in watts is 435 watts right now. Hey dudes and dudettes, did you know that Nomadic Cooling specializes in 12 and 24 or 48 volt DC powered electrical systems for your overland rig? Kenny, come with me. Let me show you what we got in stock right here. We have 200 amp hour Victron batteries, 300 amp hour Victron batteries in stock. A little bit more with me, Kenny. Come on, let me show you everything that we have in stock. We have secondary alternators, 2 and 3 belt systems, either here with the Belmar or the Wake Speed. Come on, a little bit more. Now the cabinets are a little bit bare because I'm shooting this on a Friday and we're almost out of stuff. We only use Blue Sea breakers, only Blue Sea 187 breakers over here at Nomadic Cooling. Oh, Kenny, look at this. Look at what we have. This is not an electrical system. Ooh, Baja Design lights right here. Lynx distributors in here. Let's go ahead and take a look and see. Oh, that's just sexiness right there. Let's go ahead and put that back. Don't be looking at that, Kenny. Come on, a little bit further with me, Kenny. Let's go ahead and take a look. What do we have in here? Sprinter auto starts in stock, pedal controls, CE bus, brand new CL12-100 out of Victron. This is up to 100 amps, DC power off your standard smart alternator right here. Not too many people know about this. You're trying to get DC power for under 250 bucks, Kenny. This is the guy you want. Look at that. Oh, look at that, Kenny. Take a little look-see right here. It's just beautiful. We've got Servo GX touchscreen control panels in here. We've got smart shunts. We got Stinger relays. We've got solar charge controllers, 30s and 50s in stock. This is the Victron Smart Battery Connect 220. DC bus bars. Down here, Kenny, we've only got 2 left in stock because, as I said, it's been a big week over here at Nomadic Cooling. We've got the Victron 3000 inverter. That takes your 110 to DC or your DC to 110. You want it? We got it over here at Nomadic Cooling. Now back to that beautiful smart Van Genius. Let's go. It's 3:37 p.m. We're about 12.88 volts. We're still running 38 amps. We're about 482 watts of consumption. According to the state of charge, with this mathematical calculation based on what the presets I put in, we've got about 42 minutes left on this battery, and we're at about 53% based on the state of discharge. I will notice, if you can pan down here, all the condensation coming out of the unit, Kenny. I had to put a little trash can here. On the Dometic RTX 2000, the water, the condensate is actually going to exit out the front of the AC unit. Look at all that water go. Look at all that. Look at the draining, Kenny. Get the draining in there. It's a leaker. We got a leaker, Kenny. We're at 82 degrees Fahrenheit, not in the room, but at the electrical connection, okay? Let me go here. We're at 12.87 volts, and we're at 37 amps right now of consumption per hour, 477 watts. This is the dumb part of YouTube, is I'm gonna say, wow, it's cold coming out of here, because I've been too lazy to go grab my temperature sensor, but the air is coming out cold out of here. We'll grab a temperature sensor reading before we finish this off. But basically right now we're just sort of testing exactly how long it'll run off this 100 amp Victron battery. Let's try to crush this thing, and let's figure out what if the low voltage turn off will turn this thing off. According to the reading, it's going to go for another 40 minutes. I think that's way off. So let's take a look and see exactly what it does. The air conditioner just shut off at 5:20. Had to run over here, get it going. Basically, guys, the battery is still showing almost full at 12.74 volts. The air conditioner shut off based on low voltage because the voltage drop between the battery and the unit, which is probably due to how long the cable is. And then also, this thing is also needs to be running. So, but I would like to just go ahead and just take a second. Let me turn it back on and see if we can get her to start back up again. I'm gonna get the screenshot going again just to see if we can get a little bit more time out of this thing. I mean, you guys can see the battery is almost still basically full. These Victron batteries pack a huge punch. So I know I'm looking at it. Right now it's at 3 amps. Let's see if we can increase that amperage. It takes a little bit of time. It looks like we started this right at we're at 94 amp hours consumed so far. It's a 100 amp hour battery, which sounds about right. The voltage is still super high. You remember on the lithium spectrum, the voltage drops all the way at the end of that. Maybe we can find a graph. If we do, we'll put that up. But we're gonna go ahead and basically see with the battery basically almost empty according to, you know, that we've used 94 amp hours. Let's see if we can crank this thing back up and see if we can get a little more runtime out of it. Because I think there's actually more running that we can get out of this. And remember, we didn't start the battery at 14.2 volts. We could have filled it a little bit more. So guys, look at this, what's going on right now. And you're seeing the voltage drop. Right now it's showing 12.5 basically at the battery unit. We're testing that voltage right underneath here, right underneath the unit. But remember, we got to go all the way through this wire and then back up to the unit. So at the unit, we're going to be under 12 volts. You know, I don't have a tester underneath there, but let's just say it's probably going to be like 11.8 or something. As we increase the amperage, right now we're at 33 amps, 32. You're seeing how the amps, as the amps go up, the voltage will decrease. So it may be showing 12.4 volts at the battery. Up at the air conditioner, it's going to be under actual 12 volts. It's going to be under there, what's then going to tell the computer system inside here that we have a low voltage. But when it says, I mean, Kenny, what were we at? Roughly 3 hours. You may have actually been able to get more runtime out of the battery. You know, we'll do a couple more tests. We'll do another one outside. We'll try to charge the battery a little bit more. But the information here is it's shut off based on low voltage, and now we're gonna use it again at 30 amps, 12.3 coming out. So, you know, I don't know how scientific this was, Kenny, but it's given us all the information that we need. I'm gonna go ahead and shut it down now. We'll charge it. It's pretty late in the day. We'll wait for tomorrow. We'll do it outside, and we'll see what sort of information we can get.